Okay, here we go, moment of truth. Have you ever got so deep into a project, only to find that you've come up against what feels like an insurmountable wall? Something that could stop the whole project in its tracks and make months of work useless unless you can overcome it.
This is a story about one of those projects. It's a story about feeling completely overwhelmed and out of your depth, yet still struggling through. It's also about how you can use your naivety as a tool to come up with innovative solutions and ask those seemingly stupid questions that can lead to amazing results. But I'm getting ahead of myself. Let's just start at the beginning.
So what was it that I was actually making? Well, as you've probably gathered from the videos, I live on a narrowboat. I love this lifestyle, but it does come with its challenges. We're not connected to the grid, which means that we have to get our own gas, water and electric. This is fine, as there are water taps on the canal, solar panels and petrol generators on the boat, and our gas is just the standard gas bottles you can buy anywhere.
The thing is though, my dream is to one day be completely off-grid and supply my own gas, water and electric. I want to empower myself to become completely self-sufficient, and I think this project is going to be a great first step in that direction. Out of gas, water and electric though, I think that water is probably the easiest to tackle, so I'm going to start there.
I settled on a rainwater collection system that could filter my water and double as a wall garden at the same time. I'm not going to go into depth about how I was going to build this system, as I'll hopefully be showing it in a future video. I'd already spent months on it, making models, testing prototypes, even making the whole system parametric so other people could scale it to suit their needs. There was just one little problem.
It didn't really work. Okay, maybe I'm being a little bit hyperbolic, but there was one really integral part of the design which I couldn't implement. The electronics. You see, the thing is, I kind of thought at some point I'd just pick up electronics. I mean, I make stuff on a daily basis, and most things that we use involve some kind of electronics, so I thought I'd kind of just pick it up through osmosis. Obviously, that hasn't happened.
So here I am, 2 months deep into this project, coming face to face with my inability to do basic electronics, and it sucks. I'd finally hit my moment for an epic training montage, but unfortunately in real life you can't just run up and down some steps wearing a headband and instantly level up. You have to put in the work.
So what was I going to do? I mean, I could redesign the project to work without the electronics. I'd just have to make a simpler version that didn't have all the features that I'd originally intended. Also, if I did this, I could actually finish the project in a reasonable time. Or
So I might have gone a little overboard. I didn't actually order all this stuff in one go though.
I've made this mistake before when learning something new, buying all the gear with no idea, then regretting half of it. This time I decided before I ordered anything, I'd do some peripheral research on the kind of stuff that I would need for this project.
Luckily, after a bit of googling, I realised that what I was trying to build actually had a name, a self-watering planter system. Now, knowing what I was trying to build, I started watching YouTube videos of people making similar systems, and then ordered the components that they showed in the videos. Did I know what these components did or how they worked?
No, but I kind of had a naive optimism that once I got started I could kind of just work it out. I mean, you got to start somewhere, right?
Once I had my parts, I quickly realised that I didn't know how to connect them. But who has time to learn circuit diagrams or what things actually do? I'm a man of action. I'll just... Okay, so it's pretty clear I don't know what I'm doing. And at this point I had brought a lot of new gear to get this working. Remember, I live on a boat. Space is at a premium.
If I was going to quit, I needed to do it now. I mean, I tried and surprise, surprise, electronics is hard. Who would have thought it?
The problem was, along with all the stuff I didn't know how to use, I had brought this little electronic starter set which gave you instructions on how to do a few basic projects. Again, it was super hard, and 80% of it didn't really make sense to me. But when I got this stupid little LED to blink, I realised something.
I can do this. Yes!
This was when I actually started my training montage. I went onto YouTube and watched every baby's first electronics video I could get my hands on. I tried to understand circuitry one component at a time and at my own pace. If I came across something I didn't understand, I just made a note of it and carried on. feeling confident that if I stuck with it, these questions would be answered in time as my knowledge grew. Surprisingly, in only a couple of weeks I felt ready to reattempt my water pump circuit, and this time I kind of understood what I was doing. This thing wasn't just a blue box anymore, it was a relay module, and I realised I didn't actually need to use it because in my new circuit I was using a microbit processor and could do the same job with a simple transistor. As I soldered and connected all the parts, I started getting excited. This might actually work. Yes!
This was such a big win, but I couldn't shake this feeling that something was missing. As I was putting together the circuit and learning how all these separate parts connected, I started to question if there was a better way of doing things. Whilst learning on a breadboard, I found that the connections were fiddly to put in and easy to pull out. Then, when I tried connecting the breadboard to other components, I needed to use crocodile clips, which were bulky and could short really easily. Eventually I caved and tried soldering components together, but then it was very hard to reposition components, and the soldering process itself was really fiddly and frustrating. I did have an idea of how I could fix this, but am I seriously thinking about making this project even more complicated? I just got this thing working, I should just finish the project. Or... Okay, so I've decided to go ahead and completely redesign how we make circuit boards. This isn't as crazy as it might first seem though.
As the current circuit I made the traditional way with wires and soldering doesn't fit in the case I've designed for my water system. I need something more compact like a circuit board, but easy to make with the tools that I have available to me. This is where I remembered something I'd come across in my research whilst looking into ways of making simple circuits. They're called paper circuits, and I think they're designed for teaching circuitry without the need for soldering for young kids, but this flat form factor really inspired me and got me thinking. Could I use this conductive tape in the same way that circuit boards do with copper tracks, just on a different scale? So after a bit of CAD, I came up with this. This 3D printed circuit board holds all the same components as my wired one and connects them using the conductive tape. It stacks together in layers, maintaining a small form factor, and it uses the bolts to transfer the current from the circuit board to the microbit. And best of all, it actually works. Okay, so the tick is on, so the pump should be off, but when I disconnect these crocodile clips, it should turn the pump on. Yes! Okay, so if I click the crocodile clips back together, it should turn off. This was a game changer, and something I'd not anticipated on making when starting out on this project. As I started thinking about all the potential of this new system, I realised I could make it even better with some simple tweaks. But once again, I was going off track with my original project. Was it worth it? Should I not just take what I've learned and apply it so I can finish the project?
This was when I realised that this might actually be the project. I hadn't set out to make a 3D printed circuit system, but of the two projects I felt that this definitely deserved the proper time and effort to be put into it. The old water project wasn't going anywhere either, and it might even get better once I had fully explored this circuit system. I was decided, but where do I go now? After all these previous frustrations, I realised what I needed was a modular system that could be easily reconfigured, whilst also reducing the bulk from a traditional wired circuit. Instead of designing custom tracks for each project, I created a grid that could be used more like a breadboard. I spaced the tracks to fit the tape width, and this left me with square blocks in between the tracks, which kind of reminded me of Lego bricks. I think you can see where I'm going with this.
Using the blocks, I then created 3D printed bricks which could click into the board and interface with the conductive tape. I designed these bricks so that you could mount standard electronic components to them without solder by weaving the component legs through small holes just like I did on my original circuit board design.
I love this kind of thing in design projects where the solution kind of just jumps out of the design without any real forethought on the designer's part. When stuff like this starts happening, you know your design is on the right track, but there was still just one little problem with this.
I was struggling to get consistent connection between the bricks and the track. I thought this would be an easy fix, but little did I know this would end up taking me weeks of iterative design to solve. Let's talk you through my process. First up, I started with copper tape, which was having connectivity issues, so I switched to a different tape and that worked a lot better. With this tape, I would have to sandwich wiring between layers to make stable connections, and this was not viable once I moved onto the brick connection system. Looking for other connection methods, I came across this Instructables design which used magnets and conductive thread. This led me to add magnets to my grid, which worked for most components but didn't seem to carry enough current to actuate components like servos. Although limited, this system was very quick and satisfying to use for simple circuits, with the downside of adding lots of magnets to the system. Whilst exploring this magnet system, I tried creating a different type of brick which transferred the current through magnets using ISO pin connectors. This worked well, but I eventually decided to move away from using magnets as I felt it added unneeded complexity and cost. Finally, I tried changing over to conductive fabric tape, and this worked much better. It only needed one layer compared to the copper tape, which made putting circuits together a lot quicker. That being said, the friction system of the brick still didn't hold them down well enough to the tape, so I set about creating a more reliable mechanical connection. This was achieved by designing micro flexures in the bricks, which would allow the bricks to click into the board, holding themselves in place more securely. This connection took a lot of prototyping to get right at this scale, but with this working, I was now able to get my circuits working consistently.
With all the work done on creating strong mechanical bonds between the bricks, I'd finally got my circuit board system working. I could use it to create simple circuits using standard components, or combine it with the microbit to create smart programmable circuits. There was just one more thing that I wanted to explore though: electromechanical components. An electromechanical component is the combination of a mechanical input to an electrical output, and I felt this would really leverage the 3D printable aspects of this system. To demonstrate the principle, I tried starting with the most simple electromechanical device that I could think of: a switch.
For this first switch, I printed it in 2 pieces and used magnets to hold it in its on and off state. I then applied the conductive tape to the switch to allow it to branch the circuit's connections. This had worked really well, but I'd created the system up until this point without using any magnets, so I wanted to challenge myself to see if I could do one purely mechanically. My next design used a 3D printed spring to actuate the switch, and I managed to fit it all within one module on the circuit board's grid. This took quite a lot of prototyping to get the spring size and shape just right, but eventually I created this. As you can see, the switch works really well, and it's a great proof of concept for what can be done with this system.
At this point I felt like I'd finally achieved what I'd set out to do. I had a modular expandable system which worked without the need for soldering or any special tools. There was the opportunity to expand the system to include other off-the-shelf components, and the tight constraints of the board made it really easy to design for. I think I was finally ready to put this project to bed, but there was just one last thing I wanted to do. With everything I learned from the MakerTrack system, I had to give the water pump one last shot. This time round though, I would scale the project down massively. I just needed to create a proof of concept that would show the system working on a small scale, so when I finally do revisit the water system, I'll have all the tools necessary to complete it. The plan is to create a single planter which can recirculate water when it senses the soil's moisture is too low. I'll use the MakerTrack system to put it together whilst taking on all the learnings from my previous experiments in this video.
I began by working out how small I could make the new circuit board, mocking it up with the existing components that I had. In an effort to reduce the overall size of the board, I decided to use small 3-volt coin cell batteries to power the water pump and microbit. To make this work, I created a custom holder that would allow me to click these coin cells onto the board. During initial testing these worked great, so I CAD'd up a rough case to see how all the components would come together in a full system.
This initial prototype came together surprisingly well. Too well. Something had to go wrong, and of course it did. Remember those coin cells I thought I was so clever using to save space? Well, turns out they aren't really designed for use on high load applications like this, and within 5 minutes of testing the circuit, they had almost completely drained.
With the coin cells not able to be used as a reliable source of power, I had to resort to AA batteries, which would end up doubling the size of my neat little circuit. This would also require a complete redesign of everything I just created. Back to CAD, I guess.
Okay, so I've redesigned, well, everything, and I've printed and assembled a new circuit. So now let's test it and see if we can finally call this project done.
Yeah, it was supposed to turn on when I flicked that switch.
In these videos, I try and be completely transparent and show you guys how frustrating making something new really is. It can feel really isolating every time you hit a problem like this and not know how to solve it. But I think it's important to be truthful and show the real design process without sugarcoating it. The thing is though, I've been hiding something from you guys that has helped me with this process throughout this whole video. AI. In all honesty, I didn't know if I should tell you guys that throughout this whole process, whenever I hit a wall and didn't know how to proceed, I've been asking ChatGPT for help. It kind of just felt like cheating. And in reality, I could have spent the time Googling and reading to find out the answer for myself. But that's silly. Using Google is just as much a tool as using ChatGPT is. And I don't think Googling something is cheating. So I don't think you should think ChatGPT is either. In all honesty, I don't know if I could have got this far in this project without it. As designers, we kind of have to swallow our pride and realise that we're just generalists. We're never going to be as competent in any area as the specialists, but that's okay. What we do is pull together the skills from many different disciplines to create something new. So any tool you can use to help you with that process is fair game in my book.
So back to my circuit board, and after a back and forth with ChatGPT, I've managed to troubleshoot the problem component and understand why it isn't working. With this knowledge, I now know more about transistors, how they work, and more importantly, their limitations. Luckily, it's an easy fix as I can switch it out with a component called a MOSFET. Remember, every problem, dead end, and bug is just an opportunity to learn. And in the end, after a lot of false starts and a lot of determination, you will eventually make something that just works. Yes!
We did it, guys, and I just want to say a massive thank you for watching all the way to the end of this video. This project has been a real labour of love, but if anything in it has inspired you to empower your 3D printing potential, please subscribe to our channel and check out our other projects at weareprintlab.com.